Good morning, everyone, and welcome to the second lesson for the third quarter. Now, before we start, may I present to you the objectives of this lesson. By the end of the lesson, the students must be able to, number one, illustrate the combination of objects. Number two, differentiate permutation from combination of n objects taken R at a time. And number three, solve problems involving combination. Now, before we proceed to our main topic, may we have a review of what permutation is? And we have mentioned that permutation refers to an arrangement of objects in a definitive order. That means to say that order is very important for permutation. That is, changing the order of the objects being arranged would now create a new permutation. Now we have also mentioned that there are three permutation notations. We have the permutation of n objects taken R at a time. We also have the same for the second notation and the third notation. But in our case, we have agreed that we are going to make use of the first notation, that's P of n comma R. Also have some formulae to remember when we are talking about permutation. And the first formula is n factorial all over n minus r factorial. This is permutation of n objects taken r at a time. We also have the permutation of n things, not all different. That is n factorial over p factorial, q factorial, r factorial, and so on, depending on the number of letters repeated or the number of objects repeated. We also have the third formula, that is for circular permutation, which is given by the formula n minus 1 factorial. Now, let's try to look at this problem. How many permutations can be made from the letters F, B, and O, taking two letters at a time? So, uh, when we talk about permutation, that's permutation of 3 taken 2 at a time. Okay, so that's P 3 comma 2. So that means to say that it's 3 factorial over 3 minus 2 factorial, which is 1 factorial. And 3 factorial over 1 factorial would be simplified to 6. So that means to say there are 6 permutations that can be taken or that can be formed from the letters F, B, and O, taking two letters at a time. Now, what are these 6? Let's try to list them down. We have FB, FO, BF, BO, OF, and OB. So there are actually 6 permutations in all. Now, how many combinations can be made from the letters F, B, and O, taking two letters at a time? So remember a while ago, we were able to come up with 6 permutations. This time, the problem is asking for the number of combinations. So we have FB, FO, BF, BO, OF, and OB. Now notice that I have combined or I have shaded with the same color those combinations that are the same. For example, FB and BF are two different permutations, but they speak of the same combination. FO and OF are two different permutations as well, but they would just speak of one combination because we are referring to the same letters regardless of their order. And then BO and OB are two different permutations, but they are the same combinations. Okay? So in this case, since FB and BF are the same, FO and OF are the same, and BO and OB are the same, then we have just three combinations here. Okay, so what do we exactly mean when we speak about combination? Now, when we speak of combination class, we refer to the selection of objects regardless of their order. So this differentiates now permutation from combination. For permutation, order is very important, but for combination, order is not given an importance. That is, changing the order of the objects does not create a new combination. So, regardless of order, when we talk about the same objects taken from a group of objects, that does not create a new combination. Let's try an example. Okay, consider the number of permutations of the letters A, B, C, and D taken two at a time. So it's asking for the number of permutations taken two at a time. So we have permutation of uh, n objects taken r at a time is given by the formula n factorial all over n minus r factorial, or that's equal to 4 factorial since there are 4 letters to choose from all over 4 minus 2 factorial. That therefore gives us 4 factorial over 2 factorial, which is equal to 12. Now, what are these 12 permutations? So we have A, B, and BA. That's AC and CA, AD and DA, BC and CB, BD and DB, and CD and DC. Now this gives us a total of 12 permutations in all. Okay? But when we try to look at a, B, and BA, they are just the same letters A, B, and BA. So regardless of order, it will just be one combination. So it's true, or the same is true with AC and CA, AD and DA, BC and CB, BD and DB, and CD and DC. Now notice class that there are actually 12 permutations but only 6 combinations. Now why are there only 6 combinations here? This is because the order of the objects in combination is not important. That is, A, B, and BA will take one combination. The same is true for AC and CA, AD and DA, BC and CB, BD and DB, and CD and DC takes a total of 6 combinations in all. Let's try to look at the second example. Consider the number of permutations of the letters A, B, C, and D taken 3 at a time. So, since we are talking of permutation, then we have to make use of the formula permutation of n objects taken r at a time, which is given by n factorial all over n minus r factorial. Now, since there are 4 letters to choose from and we are going to take them 3 at a time, then we have 4 factorial all over 4 minus 3 factorial, or that gives us 4 factorial over 1 factorial, which is equal now to 24. Now, what are these 24 permutations of the letters A, B, C, and D taken 3 at a time? So, let's look at the letters. We have taking the first 3 letters A, B, C first. We have A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. That gives us 6 permutations. We also have A, B, and D, ABD, ADB, BAD, BDA, DAB, and DBA. Okay, so that gives us 6 permutations as well. We also have the first letter, the third letter, and the fourth letter. So we have ACD, ADC, CAD, CDA, DAC, and DCA. That gives us a total of 6 permutations as well. Then we have the second, the third, and the fourth letters. We have BCD, BDC, CBD, CDB, DBC, and DCB. That gives us also 6 permutations. So 6 plus 6 plus 6 plus 6 will give us now a total of 24 permutations. Now notice class that there are 24 permutations but only 4 combinations. Again, this is because the order of the objects in combination is not important. Now this is illustrated below. So the first row of permutations would just take one combination. The second row would also take one combination. The third row would also take one combination, and the fourth row will also take one combination. This gives us a total of 4 combinations in all. Now, class, you might be asking me, how do we compute for the combination of n objects taken r at a time? Now, the formula is given by combination of n objects taken r at a time must be equal to n factorial all over r factorial times n minus r factorial. Now, notice, class, that it's similar or it's almost similar with the permutation formula, only that r factorial in the denominator is included. So we have, I repeat, n factorial all over r factorial times n minus r factorial. Let's illustrate our formula using our first two examples. That's combination of 4 objects taken 2 at a time. Our answer earlier was 6. So that gives us 4 factorial all over 2 factorial times 4 minus 2 factorial. That gives us 4 factorial over 2 factorial times 2 factorial, or that expands to 4 times 3 times 2 times 1 all over 2 times 1 times 2 times 1, or that gives us now an answer of 6. For combination of 4 objects taken 3 at a time, our answer earlier was 4. So that is because by using the formula 4 factorial over 3 factorial times 4 minus 3 factorial. That simplifies to 4 factorial over 3 factorial times 1 factorial, or that's 4 times 3 times 2 times 1 all over 3 times 2 times 1 times 1, or that now gives us an answer of 4. So I hope the combination formula is clear with you now, class. Let's try to have another example. Example number 3. How many ways can you select a committee of 4 students out of 10 students? So we are going to select committee members composed of 4 students, and we are going to select from 10 students. I have a note here. The arrangement or order of the students chosen is not important because anyway, they are committee members. Now, therefore, this is a combination problem where n is equal to 10 and r is equal to 4. So to solve for the problem now, we use the formula. Combination of n objects taken r at a time is given by n factorial over r factorial times n minus r factorial. Or that gives us 10 factorial all over 4 factorial times 10 minus 4 factorial. Or that simplifies to 10 factorial all over 4 factorial times 6 factorial, which when expanded will give us 10 times 9 times 8 times 7 times 6 factorial all over 4 times 3 times 2 times 1 times 6 factorial. 6 factorial and 6 factorial would cancel out, leaving us 10 times 9 times 8 times 7 all over 4 times 3 times 2 times 1, which when simplified will give us an answer of 210. Let's have the fourth example. How many triangles can be drawn on a plane using 4 non-collinear points? Again, I have a note here. A triangle is actually a geometric figure formed by forming 3 segments joining 3 non-collinear points. So our R here would be 3, and we are going to choose 3 points from 4 non-collinear points. So this is also an example of a combination problem. So using the formula, combination of n objects taken r at a time Then we have combination of 4 points taken 3 at a time. That gives us 4 factorial all over 3 factorial times 4 minus 3 factorial. Or that simplifies to 4 factorial over 3 factorial times 1 factorial, which when expanded would give us 4 times 3 factorial over 3 factorial. And 3 factorial both in the numerator and denominator would cancel out, giving us an answer of 4. Therefore, there would be 4 triangles which can be drawn on a plane using 4 non-collinear points. Let's try our fifth example. In a culinary arts class, Sam is asked to select dishes from a list of 10. How many ways can he select 6? And how many ways can he select 4? Now, there are two questions here. The first one is selecting 6 from a list of 10 dishes and selecting 4 from a list of 10 dishes. Selecting from the list of dishes needs no arrangement. Since they are all dishes, then selecting them would not require any arrangement. Therefore, the problem is a combination problem. Let's start with the first one. So using the formula, combination of 10 objects or 10 dishes taken 6 at a time would be equal to 10 factorial all over 6 factorial times 10 minus 6 factorial. Or that would simplify to 10 factorial over 6 factorial times 4 factorial, which when expanded will give us 10 times 9 times 8 times 7 times 6 all over times 6 factorial, I should say, all over 6 factorial times 4 times 3 times 2 times 1, or which gives us an answer of 210. Now, how many ways can he select 4 dishes from a list of 10 dishes? So again, we make use of the formula combination of n objects taken r at a time. So that's 10, 4. That's 10 factorial all over 4 factorial times 10 minus 4 factorial, which when simplified will give us 10 factorial over 4 factorial times 6 factorial. And when you expand it, that gives us 10 times 9 times 8 times 7 times 6 factorial over 4 times 3 times 2 times 1 times 6 factorial. Both 6 factorial in the numerator and denominator would cancel out, and that gives us an answer of 210 as well. Now notice class that the answer for combination of 10 objects taken 6 at a time and combination of 10 objects taken 4 at a time are the same. So they have the same answers of 210. It can also be shown, therefore, that the combination of 15 taken 7 at a time must be equal to combination of 15 taken 8 at a time. Or similarly, the combination of 9 objects taken 3 at a time must be the same as the combination of 9 objects taken 6 at a time. In general, therefore, class, the combination of n objects taken r at a time is the same or it's equal to the combination of n objects taken n minus r at a time. Okay, so please take note of that. I repeat, combination of n objects taken r at a time must be equal to the combination of n objects taken n minus r at a time. So let's try this. A combination of 100 taken 97 at a time must be equal to combination of 100 taken 3 at a time. Okay, because 100 minus 97 is 3. In like manner, combination of 21 taken 17 at a time must be the same as the combination of 21 taken 4 at a time, because 21 minus 17 will give us 4. So again, please take note class that the combination of n objects taken r at a time must be the same as combination of n objects taken n minus r at a time. Let's have the sixth problem. A committee of 5 students is to be chosen from 10 boys and 11 girls. How many committees can be formed if the committee is to be comprised as follows? Letter A, all are boys. Letter B, at least 4 are girls. And letter C, there are 2 boys and 3 girls. So let's start with the first problem. All are boys. If all the 5 committee members are boys, they will have to be taken from the 10 boys and none from the girls. So therefore, if the committee members are all boys, we make use of the formula combination of 10 boys taken 5 at a time. So that gives us 10 factorial all over 5 factorial times 10 minus 5 factorial. That simplifies to 10 factorial all over 5 factorial times 5 factorial. Or that is expanded to 10 times 9 times 8 times 7 times 6 times 5 factorial all over 5 times 4 times 3 times 2 times 1 times 5 factorial, which simplifies to 252. Therefore, there are 252 committees which can be formed if the committee is to be comprised with all boys. Let's try answering letter B. At least 4 are girls. Now, if there are at least 4 girls, the committee may be formed as follows. So the first option would be 4 girls and 1 boy or 5 girls. Okay? Again, there are 2 options here. The first option would be there would be 4 girls and 1 boy since the committee must be composed of 5 students, or it can also be that all the committee members are 5 girls. So in the first option, 4 girls and 1 boy, that could be the number of ways to form that would be combination of 11 taken 4 at a time. Why is that so? Because the 4 girls must be taken from the 11 girl students. So we have combination of 11 taken 4 at a time, and the 1 boy that is also a member of the committee must be taken from the list of 10 boys. So that's combination of 10 taken 1 at a time. So notice class that we are multiplying because of the word and. Again, when we speak of and, its mathematical implication would be multiplication. So that is, for the first option, we could form that using the formula combination of 11 taken 4 at a time times combination of 10 taken 1 at a time. The second option could be formed by all girls, okay? That's 5 girls, 5 girl members of the committee. So where do we take the 5 girls? Of course, they will have to be taken from the list of 11 girls. So that's combination of 11 taken 5 at a time. So what now is the total? So notice that there is also the word or. Okay, so there are 2 options, the first or the second option. So the mathematical implication of the word or is addition. So the total number of possible committees now would be combination of 11 taken 4 at a time times combination of 10 taken 1 at a time plus combination of 11 taken 5 at a time. So we now have for combination of 11 taken 4 at a time, we have 11 factorial all over 4 factorial times 11 minus 4 factorial. For combination of 10 taken 1 at a time, we have 10 factorial over 1 factorial times 10 minus 1 factorial. And for combination of 11 taken 5 at a time, that's 11 factorial all over 5 factorial times 11 minus 5 factorial. Or that gives us 11 times 10 times 9 times 8 times 7 factorial all over 4 times 3 times 2 times 1 times 7 factorial would give us 330. We have 10 times 9 factorial all over 1 times 9 factorial will give us 10. And 11 times 10 times 9 times 8 times 7 times 6 factorial over 5 times 4 times 3 times 2 times 1 times 6 factorial would give us 462. So 330 times 10 will give us 3,300 plus 462 will now give us a total of 3,762. Therefore, there would be 3,762 ways to form the committee of 5 students from a list of 10 boys and 11 girls if there would be at least 4 girls in the committee. Now let's try problem letter C. There are 2 boys and 3 girls. So it's very definite that there must be 2 boys and 3 girls. Now, where do we get the 2 boys from? We get it from a list of 10. And where do we get the 3 girls from? We get it from the list of 11 girls. So note, if there are exactly 2 boys and 3 girls, the number of committee may be determined using the fundamental principle of counting. That is, combination of 10 taken 2 at a time times the combination of 11 taken 3 at a time. So using that formula now, we have 10 factorial over 2 factorial times 10 minus 2 factorial times 11 factorial over 3 factorial times 11 minus 3 factorial. So that simplifies the 10 times 9 times 8 factorial over 2 times 1 times 8 factorial times 11 times 10 times 9 times 8 factorial over 3 times 2 times 1 times 8 factorial, which when simplified will give us 45 times 165, or that gives us a product of 7,425. Now, I also would like to introduce you class the combination of n objects taken one or more at a time. So, the shortcut for this is actually given by the formula C is equal to 2 raised to n minus 1, where n here is the number of objects to choose from. Let's try this example. Norman has 6 friends. How many ways can he invite one or more of them to dinner? Now, notice that the question is asking for the number of ways that he can invite one or more of them to dinner. Okay? So, we can use combination of 6 taken one at a time plus combination of 6 taken two at a time because we are talking of one or more plus 6 combination of 6 taken 3 at a time plus combination of 6 taken 4 at a time plus combination of 6 taken 5 at a time plus combination of 6 taken 6 at a time. So we can use that formula. Okay? But to simplify the solution, we use the formula for combination of n objects taken one or more at a time. That is 2 raised to n minus 1. So we have 2 raised to n minus 1 is the same as or replacing n with 6 because Norman has 6 friends. We have 2 raised to 6 minus 1 and 2 raised to 6 is equal to 64 minus 1. That gives us a total of 63 ways that he can invite one or more of his 6 friends for dinner. So I hope class that the formula for combination or the concept of combination is clear with you now. I'd like you to write your solution and your final answer in your notebook for this particular written work. There are only 3 problems and the complete solution and the final answer must be written in your notebook. Also, may I present to you your performance task for this particular topic. Perfect 10, your favorite family restaurant offers the following main dishes for the day: kare-kare, adobo, sisig, sinigang, bulalo, chicken inasal, ginataang salmon, and pinakbet. Now, your mother asks you to order any two of the main dishes offered. Now, using a digital infographic, explain the number of possible combinations you would be able to form. In the same digital infographic, come up with a food review of your chosen two main dishes. Share the digital infographic to your math teacher and to at least 10 friends to encourage them to dine there as well. Your digital infographic must be shared on or before 12 noon of May 4, 2021. The digital infographic must contain the following: your name, grade and section, the detailed solution of the number of possible combinations, pictures of your two chosen main dishes, and the review of your two chosen main dishes not exceeding 7 sentences. The digital infographic will be graded in terms of 1. Correctness of the solution, visual appeal of the infographic, 3. Positive use of ICT, and number 4. Food review, which includes positive and proper use of words. So that ends our class for today, class. I hope to see you next time. Stay safe and God bless us all.